So this is Jacob's Algebra, Chapter 14 Review, Part 2. So we did problems 1, 2, 3, and 5 in Set 2. Now we're going to start with number 6. So looking at number 6, it says to arrange the following numbers in order from smallest to largest. The best way to do this is to write these out vertically with the unit with the decimal places aligned. So I'm going to write out the first one, 0.027, and then the next one is 0.027 with a bar over the 7. That means the 7 is repeated, so I'm going to write a couple more 7s here. Okay, the next one is 0.027. This time the bar is over the 27. So I'm going to write the 27. Okay, whoa, I didn't align that up very well. Let me try that again. Because you need to keep these lined up in order for this to work. Okay, so we have 0.027 with a bar over the 27. So I'm going to copy the 2 7s again. Okay, and then we have 0.027 with a bar over the 0.27. So I'm going to copy the 0.27 again. So what we do now is we look at this first decimal place, all zeros. Second decimal place, all 2s. Third decimal place, all 7s. Okay, so for this next decimal place, we have nothing up here at the top. So that means that's our smallest number. So I'm going to write a 1 here. That is our smallest number. And then we have a 0 down here with a number after it. That's our second smallest number. And then we have a 2 here. So that's our third smallest number. And then right here we have a 7. So that's our fourth smallest number. So now we can write these in numerical order from smallest to largest. 1 is going to be 0.027. Our second one is going to be 0.027 with a bar over the 0.27. Our third number is going to be 0.027 with a bar over the 27. And then our last one is going to be 0.027 with a bar just over the 7. So that's how you need to arrange the numbers in order from smallest to largest. Write them all vertically. The ones that have a repeat, copy the repeat at least once, so that you can see what number would go into the next decimal place. You can see that stopping right here at this decimal place, it's pretty obvious right here exactly what order they go into. So 0.027 is the smallest, then 0.027 with the whole thing repeating, then 0.027 with the 27 repeating, and then 0.027 with just the 7 repeating. So that was number 6. Now let's look at number 7. Again, it's the set 2 problems are what we're doing right now. The set 1 problems are what I assigned for homework. So number 7 says list as many of the roots indicated for each of the following numbers as you can. If you think that there are no such roots, write none. So for part A, it says the cube roots of -64. So we want cube roots of -64. Now you can punch this into your calculator. It does work. When you do this, what you're going to get for the cube root of -64 is -4. Now, cube roots, odd roots, any odd root is there's only going to be 1. So whether you have a positive number or a negative number that you're taking an odd root of, there will only be one answer. Okay, part B says the fourth root of 81. So it's the fourth root of 81. Now your calculator is only going to give you one answer. Let me pull up the calculator here. So on this calculator, what you have to do is to get the fourth root, I'm going to hit 4. And then this root button, that's a y root x. And then I'm going to do 81. And that is not correct. Okay, so this is weird. So I have to write the 81 and then the 4 to tell it what root. Okay, that's backwards for most calculators. I know that on the TI calculator, what you have to do is first punch the root, then do second and the X root button, and then type what you want to take the root of. With the Casio calculator, you hit first whatever root you want to take. So for this, it would be, I'll just close that off. For the TI, it's going to be 4 second x root, and then 81 and equals is going to be the sequence. On the Casio calculator, it's 4 second, and I think it's actually the same kind of button, 81 and then equals. Okay, so I went and grabbed my Casio calculator to make sure what buttons it has. And on the Casio calculator, what you're going to need to do is hit the shift button and then hit the X with a little box button. What that's going to do is put you into this mode, and it's going to have a square here and a square here. And when you do that, you're going to need to type a 4 in the square that's at the top, and then use the arrow button to move over here and type an 81 in the box, and then hit equal. So on the Casio calculator, you're going to hit 4 and then the second function, and then you'll see this in the second value for the caret button, and then you'll type the 81 and equals. On the Casio calculator, you need to hit shift, and then it's the X to the box, and you can see just above that it has something that looks like this. And you will get a screen. On your screen you will see this. So you need to type the 4 into the little box at the top, and you type the 81 into the other box. So the fourth root of 81, when you put it in your calculator, once you figure out how to do the fourth root, it's going to give you an answer of 3. But the even root of any positive number is going to have 2 answers. So it's going to be plus or minus 3. Okay, number 7, part C, is the fifth root of 0. So this is what we're trying to get the answer of. Odd roots always only have one answer. That's going to be 0. In fact, even an even root of 0 would still be 0 because there's no such thing as positive or negative 0. 0 is neither positive nor negative. Okay, D, the 7th root of 128. When you punch that into your calculator, let me get that into my calculator. What you're going to get is 2. Now, this is an odd root. That means there is only one answer. For an even root, you're going to get plus or minus whatever answer the calculator gives you. For an odd root, you're going to have just one answer. Now, if you're asked to give the even root of a negative number, you will say not possible or none. So that was number 7. Now let's look at number 8. So for number 8, it says, which of these symbols greater than, equals, or less than should replace the shaded area in each of the following? So we have the fourth root of 12, and we have the cube root of 12. Well, which one do you think is going to be smaller when you take the fourth root of something or when you take the cube root of that same number? Fourth roots are going to be smaller than cube roots, so the cube root is the one that is bigger. Okay, for part B, it says, sorry, that was part A. For part B, we have the fifth root of 1 and the square root of 1. And the square root of 1. Now, in this case, it's just going to be equal because any root of 1 is 1. Any power of 1 is 1. So in this case, they're just going to be equal. Part C, we have the fourth root of 80, and then we have 3. So this one you can punch into your calculator, and if you punch in the fourth root of 80, what you're going to get is 2.99069, and it goes on. And that is less than 3. Another way to think about this is that 3 to the 4th power equals 81. So I could replace this. I could change this problem to the fourth root of 80 and the fourth root of 81. And then it's really obvious that the fourth root of 81, since it's a bigger number, is going to be a bigger answer. Okay, part D. We have the cube root of 1 over 1,000. And then we have the cube root of negative 1,000. Well, this one you don't even have to work out because the cube root of a negative number is always going to be smaller than the cube root of a positive number. So the cube root of 1,000th is going to be greater than the cube root of negative 1,000 because 1/10 is greater than negative 10. Okay, so that was number 8, which is just like number 8 in set 1. The next thing we're going to do is number 9. Number 9 says solve each of the following equations by using the quadratic formula. Simplify your answers as much as possible, but do not round them. That means do not round off anything that you get in a calculator. If you, so you either need something that terminates or you need to leave it in fractional form or radical form if it's a radical. So for number 9, part A, what we have is x squared minus 6x plus 5 equals 0. The first thing we need to do for the quadratic formula is figure out our a, b, and c. This is already in standard form because the equation is written in descending powers with a 0 on the other side. So our a is whatever number's in front of x squared. Since there's nothing there, it's understood to be a 1. Our b is whatever is in front of the x. That is negative 6. You have to make sure and grab the sign also. And then our c is the number at the end, which is a positive 5. Since it's positive, we don't have to write down the plus. And now we need to plug it into the quadratic equation. The quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm going to plug these values in. X is equal to negative b. Well, the negative of negative 6 is a positive 6. Plus or minus the square root, b squared. Well, negative 6 when we square it is 36. Minus 4 times a times c. So this is minus 4 times 1 times 5, which is 20. And all of that is over 2a. Our a is 1, so 2a is 2. Now let's work this out a little. We have 6 plus or minus the square root. 36 minus 20 is 16. So this is all over 2. And then I can simplify that some more. 6 plus or minus 4 over 2 because the square root of 16 is 4. So this is something I can actually figure out this fraction. 6 plus 4 is 10. Divided by 2 is 5. So 10 over 2 equals 5. And then 6 minus 4 is 2. Over 2 is 1. So our possible answers for x are 5 and 1. Now let's look at part B. Number 9, part B. Part B is x squared minus 6x plus 6 equals 0. Notice the only thing that changed was our c value. So our a equals 1, our b equals negative 6, and our c is now 6. So we're going to use the quadratic equation, the quadratic formula again. That's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative of negative 6 is a positive 6, plus or minus the square root of b squared. Negative 6 when we square it is 36, minus 4 times 1 times 6, that's 24, all over 2a, which is 2. So this is 6 plus or minus the square root of 12 over 2, because 36 minus 24 is 12. Okay, we're not done yet. Our x is equal to 6 plus or minus. When we look at 12, 12 can be written as 4 times 3. And then this is all over 2. So this 4 can be pulled out to become a 2. So this is 6 plus or minus 2 square root 3 over 2. That's just simplifying, which you know how to do. Now we need to simplify this fraction because notice we have a 6 and we have a 2 and we have a 2. They're all even numbers. 6 divided by 2 is 3. 2 divided by 2 is 1. So we have 3 plus or minus the square root of 3. And that's how you can leave this answer, because it says to give the